Hello everyone. In this video, we will do some examples for conditional probability. Let me start recalling the main formula for conditional probability. When you're trying to find probability of an event, knowing that another event has happened or given another event, this is conditional probability, and the formula which works for the conditional probability is the probability of the intersection divided by the probability of the given part. So that's very important to keep in mind that this part is the given event. Okay. Well, let's see this the example. Let E and F be two events defined on the same sample space, and we have the union. We have probability of E and probability of F. We are trying to find probability of conditional probability of E knowing F, which we know that is probability of the intersection divided by probability of the given part. But how we are going to find probability of the intersection here? Well, here we have probability of union, probability of each one of the events. So we can go ahead and use the formula for the inclusion-exclusion formula. So here, probability of the intersection is equal to probability of sums of probabilities of each one of these events minus probability of union. So this is a formula that we have been using. Sometimes the other way around, union is on the left hand side and intersection is on the right hand side, but both are the same formulas. Okay, so here I have 0.4 plus 0.6 minus 0.7. So that is 0.3. Well, we found probability of the intersection. Now we can put it back here and write this is 0.3. Probability of F is 0.6. And well, I want to simplify this. There are different ways to do this, but the way I like it, 0.3 is 3 over 10. 0.6 is 6 over 10. And then you can cancel the tens in the denominator of the numerator and denominator, and that will give you just 3 over 6, which is 1 over 2. And by the way, when you do this work of the intersection, well, now you have the probability union F and E. And well, you can actually find all the probabilities that you're looking for here, because now I can complete my Venn diagram. So this is E, this is F. I know that the intersection is 0.3. F, the whole event F has probability 0.6, but 0.3 is in the intersection, so the rest will go here. And probability of the event E is 0.4, so 0.1 will come here. And then 0.7 is what we have for the union. Outside is going to be 0.3. So this is the Venn diagram that we will be able to use from for the other parts, as you will see very soon. But basically, we have all the information that we can get for events with those properties. Okay, so let's just go now here, try to find probability of F given E. The formula for this is find the probability of the intersection divided by probability of the given part. This is very important. The denominator should have the probability of the given event. So probability of E is 0.4. Probability of intersection we just found up there. So this will give me 3 over 4. And that is the number that I'm looking for. probability of E given F complement. Here, well, write the formula first, yes. See what you need and where you can get those ones. Okay, we need intersection of E and F complement, and we need probability of F complement. Well, remember the probability of complement is can be computed easily by knowing probability of F itself. So in this case, we have 1 minus probability of F, which is 0.6, and that is 0.4. How about probability of the intersection of E and F complement? Here you can do two different methods. Here one would be using the formulas and the other one would be Venn diagram. So remember the Venn diagram that we just finished up there was like this, yes. So this is E, this is F, 0.3, 0.3, 0.1, and outside is 0.3. Now we are looking for probability of E intersect F complement, the region which is inside E but outside F. So that is what we are looking for. So that is E intersect F complement, and its probability is 0.1. Okay, so that's one way of getting this number for the intersection. There's another way, which is using formulas, and here remember that partitioning an event using another event. So here if I have probability of E, so I can partition it into two pieces, the parts which are in E and F and the parts which are in E but not in F. That's a partition for E. So we have that formula. 0.4 is probability of E, 0.3 is probability of intersection. So the probability of intersection of E and F complement then will be probability of E F complement is 0.4 minus 0.3, which is 0.1. So either way, you find this number, and then it's time to go back to the original formula that we started with. So here I have 0.1 in the numerator, 0.4 in the denominator. 1/4 is the number I have. Well, this you can even go further and write it at 0.25. Okay. And the last one, I believe, yes. Probability of E complement intersection F complement. First, write or break it down using the formula. See what parts you need to find first. So we already found that probability of F complement is 1 minus probability of F, which is 0.6. So 0.4 is what we have there. For the intersection of the complements, let's first start with doing it by Venn diagram, because we have all the information on the Venn diagram, and if you're good with Venn diagrams, it will make your life much easier. But you have to be careful, because there are some subtleties there that you have to practice enough to be able to see those subtleties. So what is E complement intersection F complement? So this is the region which is outside F and outside E. So the part which is not included in F and not included in E. And as you can see, this shaded area is what we are looking for. This is E complement intersect F complement, and from there you just notice that, oh, I already found those numbers there. That is 0.3. Well, you can do the formula as well, because here you see that E complement intersect F complement. If you use the De Morgan's law, or try to write this thing as complement of one thing, you can write it, but you have to make sure that you turn the intersection to union. And since you have that, then probability of this part is going to be probability of the complement of the union, and that is 1 minus probability of union, which is given here, and it is 1 minus 0.7, which gives me 0.3. So as you see, both of them giving me the same number. Now I can go back and plug in the numbers there, and that is 3/4 or 0.75. So just by knowing what is the formula and how to get different parts of it, you will be able to get conditional probability. I have another problem here that we go the other way around here. In this example, we have the conditional, and then we will go backward and find the probability of intersection. So let me start with the question. We have two events, E and F. We are trying to find probability of union, and probability of each part is given. Probability of the conditional probability of E knowing F is also given. While seeing the union probability of E and F, the first thing you should come to your mind is that we are looking for, one good formula to use here is probability of inclusion-exclusion principle, yes? So sums of probabilities minus probability of E intersect F. So we have this one, but we don't have intersection, probability of intersection. But since the conditional probability is given, remember that probability of E knowing F is equal to probability of intersection. That's what we want to find, divided by probability of F, the given part. But see, the left-hand side is given. This is 0.3. The right-hand side, the numerator, is what we are trying to find. And the right-hand side, the denominator, is 0.5, is given. Now you just need to multiply this to the other side and get the probability of the intersection. And that is 0.15. Okay, now having that, I can go back and use the formula that I prepared there. 0.25 is probability of E, 0.5 is probability of F. Now I have probability of intersection, that is 0.75 minus 0.15, which is 0.6 or 60%. Okay? So just a formula. You may go backward. Knowing conditional probability, you can find the probability of the intersection, or as you saw in these cases, knowing the intersection, we can go and find probabilities of conditional probabilities.